Hi and welcome to this final video on this buoyancy and hydrodynamic series. So I want to just complete this answer that I gave a few days ago. So here I gave a very basic example on how to generate a robot that by drag or lift moves around a fluid based on this question that asked basically that more information about how to do this. So here was a basic example with a sphere and just a tiny fin tail that moved around. In this case, I want to give a more complex example, which is this. This is a simplified geometric version of the narrow robot, which is a robotic fish that I've made some videos about it to generate the meshes and also to make it zero or neutral buoyancy. And here I just want to show you how you can make this robot fish move around in a fluid. Obviously you'll have to do it with better controllers and do it much better to make it the final product, but this is a starting point of how to do it. So as we talked about in the previous video about generating drag, I've added these plugins, which are lib, lift, drag plugin, and I've added 3. These are for the caudal fin link, which is this one, this purple disc, and then for the other 2, which are the pectoral fins, which would make it go up and down and roll. And this tail makes it move forwards and backwards, depending on how you move the tail. So what's different about this? Well, there are 2 main differences. One is the area that I'm giving it. So you have to calculate the area of each element. So in this case, this element was exactly the same as the example that we gave in the previous video, but these ones are totally different. So you have to calculate the area of a prismatic shape. No difficulty there, I suppose. And one of the things that can give you more problems is where you situate the center of pressure, which is very important, and how you consider what is upwards and what is forwards, because that will condition how the forces of drag are applied. So you have to, a good thing is running RViz. When you have the model, you run RViz and see how this is situated. Sorry, I have to hit play first. There we go. So as you can see, it stops quite immediately. Why? Because it has friction. If it hadn't friction, it would just oscillate because there wouldn't be any friction in the water. So any differences in mass and so on, it would make it move. So in this case, it's totally stopped there. So if we launch RViz again, hopefully we now have it exactly. So here you can see, if you add a TF, you can see all the frames, and with that you can know what you have to consider upwards, forwards, and so on. In this case, I've considered, if you go here, I've considered upwards for the Z-axis. So that would be this one, which makes sense because I'm trying to generate forces in this axis, so that's good. And then forwards. So in this case, I'm considering forwards as X. So this one. Basically, I've made it this way so that it generates a drag that is physically coherent. So when you move this tail around, it generates forces in the Z direction. Okay? So this is important. The best way is just, if you're confused, just use the standard. So what you would consider in a cylinder as upwards, and what would you consider as forwards in a cylinder, and from there you can test and change the axis so that it makes what you want it to do. Okay. So this is the case of the caudal fin. In the case of the the pectoral fins, we have them here. So as you can see, we are considering, in this case, upwards X and forwards the Y. But I mean, it depends on how you want to put it. And in this case, I've used plus. So I've considered this as a positive. It's just as it should work. It works better for you. Okay. Once you have it, you just have to move it around and see what happens. So if we cancel this and we do the RQT where we have access to the controllers, then I'm going to just move the basic, not the whole tail, but just one part. So there we go. We are moving with sine 100. So as you can see, it started to move and go up, forwards in this case. So there you go. So this tail is generating a drag upwards, and it's moving in this direction. Yeah. If, for example, we activate now, let's say, the other ones. Whoops, sorry. There we go. So now it goes faster. Whoops, sorry. There we go. So it depends on the controller, and as I told you, now is the time for you to make very good controllers so that it moves as it should. So in this case, it's just a raw controller. Yeah, and that's it. It's just a matter. The basics is knowing which are the axes that you want to generate the force to, and then calculate the area. So more area, you'll have more drag, and that's quite it. And then generate the controllers so that it moves around. Yeah. So thank you very much for watching this tiny short video, and hope it was useful, all these buoyancy and drag tutorials. And if you want to know more about robotics, just subscribe to our channel and hit that bell button to have the notifications. And that's it. Thank you very much, and see you soon. Bye.